Today we are going to learn about inclined plane. We are going to see what is an inclined plane, what is the force required to lift an object vertically upwards and on an inclined plane. We are going to see the work done on lifting a load vertically upwards and on an inclined plane, and we are going to see mechanical advantage of an inclined plane. Okay, so let us begin. Now, what is a simple machine? What is a machine or what is a simple machine? A simple machine is a machine or is a device which helps us to do the work easier. A very simple definition. Simple machine helps us to make the work easier. Okay. Secondly, what is an inclined plane? An inclined plane is one of the 6 simple machines. So, an inclined plane is a simple machine. Now, let us see, this is an inclined plane. We have to lift a weight of 5 kg on the inclined plane and vertically upward. So, let us see what is the force required to lift the load vertically upwards to a height of 10 meter and on an inclined plane to the same height. The inclined plane or the plank or the ramp is making an angle of 30 degree with the horizontal. Now, as you know that force is equal to mass into acceleration. Here, if this person lifts this weight vertically upwards to a height of 10 meters, the force required will be mass, which is equal to 5 kg, into acceleration due to gravity, that is 9.8, which will be equal to 49 Newton. It is clear. Now, if the same load we are lifting to the same height through this inclined plane, then what will be the force required? Now, as we know that the parallel component of force will be mg sin theta. Let us take force is equal to mass into gravity into sin theta. That is, force is equal to mass into acceleration into sin theta. That is mg sin theta. So, the force required to lift the load on this inclined plane will be mg sin theta. Mass is 5, acceleration due to gravity is 9.8, and sin theta, the value of sin 30 is equal to 0.5. So, it comes to 24.5. Now, what can you say? If we are lifting the load vertically, we require a force of 49 Newton. The same load, if we are lifting it on a ramp, we will require half the force. So, now, as we have seen, inclined plane is a simple machine. What can you see from this calculation? From this calculation, we can see that we have to move the box twice the distance as in lifting upward. We have to move this box twice the distance as lifting it upward. Hence, force is reduced to half. So, in an inclined plane, you require a less effort or a less force to push the load, then you are lifting it upward. Is it clear? Okay. Now, why it is required? Because work is spread at a longer distance. Now, here you are lifting the load through a smaller distance. The same work you are pushing it through a longer distance. That is why the work is spread at a longer distance. Hence, we have less effort. And the effort what you required will be less. Now, we have seen what is the inclined plane. We have seen the force required to lift the load vertically upward and against inclined plane. So, when you are pushing the load on an inclined plane, you require half the effort. Now, let us come to the work done. Now, when you are lifting this work upwards, the work done will be equal to mgh, that is mass into gravity into height. So, it becomes 490 joules. When you are lifting or when you are pushing this load on the inclined plane, the work done will be equal to, now here you have sine of theta is equal to opposite side upon hypotenuse. That will be equal to h upon L. So, h will be equal to n sin theta. Same formula you use, mgh, except in the place of h, you put this formula, n sin theta. So, here again you get mgh. So, it is same. So, what we can conclude? The work done will be same when you are either you are lifting the load vertically upwards or you are pushing it through a ramp. The work done will be same, but the force required will be less. This is the basic advantage of inclined plane. Now you can see this example. This we very often see this on the roads. Whenever you are pushing some box or a barrel, and when you want to put it in the truck, it is very difficult to put it vertically upward, and it is very easy to push it through a ramp. Now here again, if this angle will go on decreasing, you will require less and less effort. That means as this distance will go on increasing, your effort required will go on reducing. But your distance where you are pushing, the distance through which you are pushing will be more. Clear? Now we will come to, now we have seen what is the force required. The force required is always less when you are pushing it through an inclined plane, then you are lifting it vertically upward. The work done is same whether you are lifting it vertically upwards or you are pushing it. Now let us see what is the mechanical advantage. Mechanical advantage is given by the formula length of the inclined plane divided by height of the inclined plane, or I have also written as ramp because the inclined plane is also called a ramp. Now let us have a quick recap. What is the inclined plane? Inclined plane is also called a ramp. What are the advantages? What are the other this thing for inclined plane or defining inclined plane? It is a plank or it is a ramp where one end is at higher end and the other end is at lower end. The advantages is to lift heavier loads with less effort or less force. What is the mechanical advantage? Mechanical advantage is a factor by which the force is reduced. Now here what is the mechanical advantage? 20 divided by 10, that will be 2. So the factor is 2. So it becomes twice as easier to push the load than what you are lifting it vertically upwards. Thank you.